Hi students, today I am continuing the chapter Continuity and Differentiability and I am going to discuss derivatives of composite function. Derivative of composite function. There are two types of functions. First one is called as standard function and second one is called as composite function. Any function, an example of standard functions are, we know that x, sin x, cos x, x square, x cube, etc. In case of composite function, any function in which x is replaced by another function is called as a composite function. Means, if I say there is a function sin x is the standard function, but if I say x is replaced by another term, say x square, that means sin x square. Our function will become sin x square is a composite function. So f of x equal to, let us take f of x, our function f of x equal to sin x square. Next, I am going to explain how to find out derivative of composite function. Okay. Let us take our function be sin x square. So, differentiating this composite function, we know that differentiating with respect to x, it can be write as f dash of x or d by dx of f of x, which is equal to first we need to find the derivative of sin x square by using the standard form comparing with derivative of sin x. Okay. We know that the derivative of sin x is equal to cos x. Right. But here derivative of sin x square will be cos x square. Okay. So what is the difference between a composite and standard function? We have used the same formula. The difference is that the part which is replacing x will be derivative of that. So we will multiply the derivative of x square and we get cos x square into what is the we know that the derivative of x square is 2x. So replacing 2x here, we get our answer 2x into cos x square. This is our final answer. Okay. The derivative of f of x can be represented by f dash of x or d by dx of f of x. And we know that the derivative of x square is equal to 2x. Okay, but here it is not x square, it is 2x plus 1 all square. Okay, it is 2x plus 1 all square. So, derivative of 2x plus 1 all square is equal to 2 into 2x plus 1 into derivative of 2x plus 1. That is derivative of the function. Here 2x plus 1 is the function. So, we write derivative of 2x plus 1 here. Here we need to find out the derivative of 2x plus 1 and right here. So 2 into 2x plus 1 into derivative of 2x is 2 is a constant, and we know that the derivative of x is equal to 1. So 2 into 1 equal to 2. And derivative of 1 is a constant, so derivative of 1 will be equal to 0. Finally 2 into 2 equal to 4. So we write 4 into 2x plus 1. Okay. Once again I repeat, we need to find out the derivative of two functions here. First one is the derivative of function in the form of x square. Next one is we differentiate the function. Okay, again we differentiate the function and multiply with our first function, derivative of first function. Okay, this is our next example. F of x equal to sine of cos of x square. Here we can see that this question consists of three functions, sine x, cos x and x square. Three standard functions, right? Sine x, cos x and x square are three standard functions. Okay, so let's start finding the derivative of this composite function. D by dx of f of x equal to, or f dash of x equal to derivative of d by dx of sine of cos of x square. Don't forget, here this function consists of three standard functions. Okay, so we need to find out a derivative of these three functions. First, we know that the derivative of standard function sine x equal to cos x. Here derivative of sine of cos x square, so it will become cos of derivative of sine of cos of x square become cos of, here x is cos of x square, right? So write here cos of cos x square into derivative of next standard function is cos x square, right? Okay, next function is cos x square, so we need to find derivative of cos x square. So write first term, it remains same, cos of cos x square into the derivative of cos x. We know that the derivative of cos x is minus sin x, but here derivative of cos x square, so derivative of cos x square will be minus sin x square. X is replaced by x square. Don't forget to write x square into x square is another function. So we must find out the derivative of x square. So write here. Next, the first two terms will remain same. So write cos of cos x square into sin x square. Derivative of, we know that the derivative of x square is 2x. So write 2x here. And this will be our final answer. And don't forget to write minus here. Okay. So in this question, here this function consists of three functions, sin x, cos x and x square. So we need to find out three derivative. Okay, I hope you understood. This is our first question. In this question, we need to differentiate the function with respect to x. And the function equal to sec of tan of root x. And we can see that this function consists of three functions, three standard functions, sec x, tan x and root x. Okay, so let's start the solution of this question. F dash of x equal to, what is the derivative of sec x? D by dx of sec of tan of root x right here. And we know that the derivative of sec x, first function is standard form is sec x. So derivative of sec x will be sec x into tan x. Here x is replaced by tan root x. Don't forget to write x is replaced by tan root x. Okay. So our derivative of sec of tan of root x will be sec of tan root x, tan of tan root x into next function is tan root x. So we need to find derivative of tan root x. Okay. And we know that the derivative of tan x in standard form is sec square x. But here tan of we need to find the derivative of tan root x. Tan root x, but here x is replaced by root x. So d by derivative of tan root x will be sec square root x. So don't forget to write the first term, sec of tan root x and tan of tan root x. Then write derivative of tan root x will be sec square of root x. Next function is root x. So write derivative of root x here. Okay. What is the derivative of root x? We know that the derivative of root x in standard form will be 1 by 2 root x. Okay. We know that the derivative of x raised to n is n into x raised to n minus 1, and root x can also be written as 1 x raised to 1 by 2. Here comparing these two, n is equal to 1 by 2. So write replacing n by 1 by 2 here, we get the derivative of x raised to 1 by 2 as 1 by 2 into x raised to 1 by 2 minus 1. X raised to 1 by 2 minus 1 means x raised to minus half, and that will be equal to 1 by 2 root x, or x raised to 1 by 2 can be also written as root x. Okay, 1 by 2 root x. Okay, this is how we get derivative of root x is equal to 1 by 2 root x. Okay, I hope you remember we had studied this term in plus 1. So here replacing the derivative of root x by 1 by 2 root x, the first and second term will remain same. Sec of tan root x into tan of tan root x into sec square root x into derivative of root x will be changes to replaced by 1 by 2 root x. So write 1 by 2 root x here. This will be our final answer. I hope you understood. So don't forget to write the first and second terms. Okay, this question consists of three standard functions. So we need to find three derivatives here. Okay, first one is derivative of sec x. We know that derivative of sec x is sec x tan x. Okay, here x is replaced by tan root x. Okay, tan root x. And second one is derivative of tan x. We know that the derivative of tan x is sec square x. Here we need to find the derivative of tan root x. So x is replaced by root x. So answer will be answer of that term will be sec square of root x. Okay, and last one is we need to find the derivative of root x. This is our third function. So we need to write the derivative of root x. This is our next question. In this question, we need to differentiate the given function sine of ax plus b divided by cos of cx plus d with respect to x. Here we can see that the denominator and numerator are composite function. We know that u by v method is used for differentiating a fractional function. So what will be u by v method? We know that v into u dash minus u into v dash divided by v square. That is denominator into derivative of first function minus numerator into derivative of second function divided by denominator square. Okay. I hope you remember the quotient rule. F dash of x equal to u, that means denominator cos of cx plus d into derivative of numerator, that is d by dx of sine ax plus b, minus u, that means numerator sine of ax plus b into derivative of denominator, that means d by dx into cos of cx plus d whole divided by denominator square. So write cos of cx plus d whole square here, which will be equal to cos of cx plus d, which will remain same, into derivative of sine ax plus b. We know that the standard form of derivative of sine x is cos x. Here we need to find derivative of sine ax plus b, which will be equal to cos of ax plus b. Okay, x is replaced by ax plus b. So cos of ax plus b into derivative of, we need to write the derivative of next function. Here the function is ax plus b minus, next one is second term sine of ax plus b into derivative of cos cx plus d. We know that the standard form of derivative of cos x is minus sin x, but here we need to find derivative of cos cx plus d, which will be equal to minus sine of cx plus d, that is x is replaced by cx plus d into derivative of our function cx plus d whole divided by cos of cx plus d all square. We know that cos theta whole square is equal to cos square theta. So denominator we get cos square cx plus d, which will further equal to write the first term first two term will remain same, that is cos of cx plus d into cos of ax plus b. Next we need to find the derivative of ax plus b. Derivative of ax, a is constant, derivative of x is 1, so a into 1, so a into 1 will be a. Next derivative of b is a constant, we know that derivative of a constant is 0, so it will become a into 1 plus 0 or a into 1. Okay, minus, these two minus will changes to plus. Next write the next two terms will remain same, sin of ax plus b into sin of cx plus d. Next we need to find out the derivative of cx plus d. Similarly, derivative of cx, c is a constant, derivative of x is 1, c into 1 is c, and derivative of d is a constant, derivative of a constant, we know that derivative of constant is 0, so c into 1 alone here, we write c into 1 alone, whole divided by cos square cx plus d, which will be further equal to, just rearranging this term, a into cos cx plus d into cos ax plus b plus, write c first, and we get c into sin ax plus b into sin cx plus d, whole divided by cos square cx plus d. This will be our final answer. So in this question, here we are using quotient rule. So do carefully each and every step. In this question, we need to differentiate the function with respect to x. Here the function is f of x equal to x cos of x square. Okay. So here we are using product rule. And what is product rule? uv whole dash is equal to u into v dash plus v into u dash. That means first function into derivative of second function plus second function into derivative of first function. Okay. So f dash of x equal to, first function is x, second function is cos x square. So x into derivative of second function is cos x square plus second function cos x square into derivative of first function d by dx of x. Here cos x square is a composite function, right? So which will be equal to x into, we need to find the derivative of cos x square. The standard form of derivative of cos x is minus sin x, but here derivative of we need to find the derivative of cos x square. So it will be equal to minus sin x square, and don't forget to write here it is a next function is x square, so we need to write a derivative of x square. We need to find derivative of x square plus cos x square into derivative of x, and we know that the derivative of x is 1, right, which will be equal to minus x into sin x square. We know that the derivative of x square is 2x, equal to derivative of x square is equal to 2x. So replacing derivative of x square by 2x plus cos x square into 1 is cos x square, and rearranging this 2x into x means 2x square, x into 2x means 2x square, into sin x square plus cos x square. Okay, this will be our final answer. So here in this question we are using product rule. Here cos x square is a composite function. Don't forget to write the derivative of x square. This is our next question. In this question, given that a function f of x equal to 2 into root of cot of x square, we need to find f dash of x. So let's start the solution of this question. Given that function f of x is equal to 2 into root of cot of x square. This function, we can see that this function consists of 3 standard form. First one is root x, standard function. Okay, we can see that this function consists of 3 standard functions. That are, first one is root x, second one is cot x, third function is x square. Okay, so let's start. F dash of x is equal to, we know that 2 is a constant, so write 2 here. What is the derivative, standard form of derivative of root x? We know that the derivative of root x is 1 by 2 root x. But here we need to find the derivative of root of cot x square. If derivative of root x is 1 by 2 root x, then root of cot x square will be 1 by 2 root of cot of x square. That is, we are replacing x by cot x square. Okay, into next function is cot x square. So we need to find the derivative of next function is cot x square. So derivative of cot x square. Okay, and these two will cancel each other. We get 1 by root of cot of x square, and we know that the derivative of cot x is minus cosec square x. If derivative of cot x is minus cosec square x, then derivative of cot x square will be minus cosec square x square. Here x is replaced by x square. Okay, and next function is x square. So next we are going to write derivative of x square here. Okay, which will be equal to minus cosec square of x square divided by root of cot x square. And what is the derivative of standard form of x square? We know that a standard form of derivative of x square is 2x. So we replacing the derivative of x square by 2x here. So final answer will be minus 2x into cosec square x square whole divided by root of cot x square. I hope you understood. Here firstly this function consists of 3 standard functions. First one is root x, second one is cot x, third one is x square. Okay, so we need to find all the derivative of these 3 functions. Okay, so first one is first we are using the derivative of root x. Here root of cot x square, we need to find the derivative of root of cot x square, and which will be equal to 1 by 2 root of cot x square. And don't forget to write the derivative of next function cot x square. Okay, and we know that the derivative of cot x is minus cosec square x. But here we need to find the derivative of cot x square, and this x is replaced by x square. Then we write minus cosec square x square. This is our next function is x square. So we are writing derivative of x square here. Okay. So finally we get minus cosec square x square by root of cot x square. The derivative of x square is 2x. And just rearranging this we get our final answer. Okay, I hope you understood.